Hi, welcome to our business statistics video series. This week's video is basic probability. This comes out of our textbook in chapter 5, and the learning objectives that we'll be looking at are to define the terms probability, experiment, event, and outcome. And then we're going to assign probabilities using a classical, empirical, or subjective approach. Probability is measured as a value between 0 and 1, describing the relative possibility that an event will occur. In our examples down below, we have a 0.5 probability would be the same as a flipping a coin and getting getting a heads. So 50-50, right? Then on the bottom end of the spectrum, we have the probability that our sun will disappear this year. And we assign that a probability of 0 in that we believe it cannot happen. And then on the other end of the spectrum, we have something that is sure to happen, the chance of rain in Florida this year. And that is assigned a probability of 1. Probability can also be defined as an experiment, which is a process that leads to the occurrence of one and only one of several possible results. These results are called outcomes. They are the particular result of our experiment. And an event is the collection of one or more outcomes of the experiment. So down below we have a chart exhibiting two possible scenarios. And the first one, our experiment, is that we roll a die. All possible outcomes that we can get from rolling a regular 6-sided die would be a 1, a 2, a 3, a 4, a 5, or a 6. So those are all the possible outcomes from our experiment. Then some possible events that we might define would be the chance of getting an even number, or the chance of getting a number greater than 4, or the chance of observing a number 3 or less. So the chances or the event to observe an even number would be to observe a 2, observe a 4, or observe a 6. Those are the 3 possible outcomes that would make up our event. The second experiment we're talking about would be to count the number of board of directors for a Fortune 500 companies who are over 60 years of age. So in this scenario, all the possible outcomes, we can start with none are over 60, and it would go all the way up until we get to all of the Fortune 500 company board members, and we could have any of the outcomes that we could get from all the way from 0 all the way up to all. Some possible events from this would be more than 13 are over 60, or fewer than 20 are over 60. When we talk about probability, we'll talk about 3 different main types of probability. The first is classical probability. This is when the probability of an event is equal to the number of favorable outcomes divided by the total number of possible outcomes. And in general, the odds of getting any one of those outcomes is equal to all of the others. Rolling a die is an example of classical probability because each outcome that we have has an equal chance of occurring. So, for example, looking at this, we have what is the probability of the event, an even number of spots appear face up. Our possible outcomes, we already defined those, anywhere from 1 to 6. And in this case, there are 3 favorable outcomes, getting a 2, a 4, and a 6, and the collection of 6 equally likely possible outcomes. So this would mean 3 outcomes are favorable out of a total of 6 possible outcomes, giving us a probability of 0.5 for the event, an even number of spots appear face up. The key with classical probability is that the outcomes are equally likely. Empirical probability takes a look at the past and sees what has happened in similar events in the past in order to predict or to give us the probability of an event happening in the future. The empirical approach to probability is based on what's called the law of large numbers. which essentially means over a large number of trials, so the more times we roll the dice, for example, or the more executives that we survey, the empirical probability of an event will approach its true probability. The key to establishing probabilities empirically is that a larger number of observations provides a more accurate estimate of the probability. So, for example, if we took our dice example and rolled the die 5 times, and each of those times we got an odd number, our empirical probability based on our trials would be 5 out of 5. So it's 100% chance, or a 1%, a probability of 1 that we will get an odd number based on our empirical evidence. Now, obviously, that's not true, but with those 5 particular rolls, that's the result we got. If we then went and rolled the die 100 times, our results would be far more likely to reflect our classical probability with 1 out of 6 for getting any particular number, and then to get an odd number would be 0.5. Another example would be on February 1st, 2003, the Space Shuttle Columbia exploded. This was the second disaster in 123 space missions for the shuttle. On the basis of this information, what is the probability that a future mission is successfully completed? So we're taking the past to give us the probability of a successful flight. And that probability of a successful flight, we take the number of successful flights, in this case 121, and we divide it by the total number of flights, 123. That gives us a probability of a successful flight of 0.98. Finally, we have subjective probability. Subjective concept of probability is the likelihood or probability of a particular event happening that is assigned by an individual based on whatever information is available to that individual. These are things that are not as easily measured as a roll of a die or looking at just past behaviors. If there's little or no data or information in order to calculate a probability, it may be arrived at subjectively. So some examples of this would be estimating the likelihood that the New England Patriots will play in the Super Bowl next year. Now, we can use some of the empirical data we have and look at that, but we don't know everything that's going to happen. We don't know if Tom Brady will be suspended or hurt, or if Bill Belichick will retire. We don't know a lot of the information right now. But we can make an estimate or make a guess. Number 2, we could estimate the likelihood of a person being married before the age of 30. And this is a specific person, not just any person. If we were predicting for any person, we could just use the empirical probability, take all the people that were married before 30, divided by the total number of people that are 30, and figure that out. However, being able to predict one person just using that empirical probability probably doesn't give us all of the information we need. So if that person, for example, comes from a very religious family, a religious background, where people tend to get married earlier, then we might be able to have estimate the probability as much higher than the regular empirical probability. Finally, another example would be to estimate the likelihood of the U.S. budget deficit being reduced by half in the next 10 years. Depending on your political views, this could be a certainty to you, and you could ascribe it as a probability of near 1, or you might think that this is impossible and will never happen, and then you assign it a probability of 0. To sum up probability, there's two major branches of approaches. We have our objective and subjective. The objective can be further broken down into classical probability, which is based on equally likely outcomes, and empirical probability, which is based on relative frequencies, so the relative amount of times something has happened in the past. And subjective, of course, is based on the available information. This concludes our video on basic probability. Thank you.